Hello. You're on mute, Vishali. Sorry, you're on mute.
Sorry.
That's all right.
Welcome. Welcome to the Terraform series, where today we will be discussing about interact with Terraform modules with Brad and Ben. So let's start.
Yeah, would you like to introduce yourself first, maybe?
So my name is Rukshali. I am a student pursuing BTech from India, and I'm just loving this cloud native mentoring sessions. I'm enjoying them. I'm learning a lot. I have learned a lot about Terraform from last 1 month. Really, you have to join this.
Yeah. And Ben, would you like to introduce yourself as well?
Yeah, sure. But first, let's give the stage to Vrshali. This is actually her second time. She's a return guest on the HashiCorp user group. So welcome back, Vrshali. We're glad to have you
Thank
here
you.
again. So yeah, as
Thank-
Vrshali had mentioned, my name is Ben. I've been doing a few of these talks as well at HashiCorp user group, as well as this mentoring chat and this mentoring channel. And well, the mentoring channel is basically hosted by Brad himself. So this is a good segue to pass it over to Brad.
Yeah. Thanks everyone for joining. My name is Brad, as you know, and yeah, this is a series we have. We have around 10 talks, and it's all about the path to getting your Terraform certification as well. So this one's on modules, which is probably going to be my favorite talk. And yeah, without further ado, let's get started. So how do we want to do this today? Do we want to, Brookside, do you want to, Ben and I, do you want to, should we first talk about modules to start off with, and then we can get into more of a practical example as well? So,
You sure can.
yeah, I guess maybe while he's here, yeah, we have a lot of people, so thanks for coming, everyone. So I guess maybe I can start from, maybe 3 or 4 years ago when I started using Terraform. So I didn't do any certification or anything, and I just jumped straight into it. So what I first started doing is I made a resource, and I didn't use modules, and that was fine. But what I found myself doing is copying a lot of the code, and when you're doing software engineering, you want to make as much code as you can reusable and modular. So I found myself, having thousands of lines of code when really it only needed to be a couple hundred. So I then got introduced to modules, and then I would actually have my modules in a folder on the same repo as well. And that was good because that made my code more efficient, and I could use things like IAM roles, and I could reuse those and make it more efficient. And then after more experience, I then found out, because I've always been using open source. I've never really been that interested in Terraform Cloud or Enterprise, even though it's a great tool. I feel like as a sort of open source person, I always want to leverage open source and build those little wrappers on the top. So I then used Git, so putting my modules in Git in a separate repo. That was really good as well. And then when we had maybe 6 development teams, they could reference those modules and pull them in. One thing we found bad with that as well is that if we did a change to it, it could be a breaking change. So then the iteration next was to then version control those modules as well into releases. So yeah, as the years have passed, I've got better and better with using modules, and maybe today we want to demonstrate a good practice for them. And then, so we have a question already. So which cloud are we using? So today we'll probably use AWS. I know all clouds, so if you have any other questions specific to GCP or Azure, more than happy to answer that as well. So today we're going to work on a EKS. So our goal is going to be we probably won't have time to finish all of it today, but our goal will be to provision the EKS cluster and leverage Terraform modules doing that. So is there anything else you'd like to add about that, Ben?
No, you've covered most of it. Modules basically just a way to not repeat yourself. It's just like any other method or function in any language.
Yeah. All right. And then, so while it's here, Steve, I'll work off. I'm not sure what that one means, but yeah. Okay, so Rukshali, would you like to share your screen, or how do you want to do it today? Would you like to start doing some coding and we can show you how it's done?
No, like I haven't prepared much for.
That's even better, because it's good that we show the folks that, you know, we expect people here to be, you know, not know anything about it. So it's actually better if you haven't prepared. So have you cloned my EKS repo with the way?
Yes, yes, yes.
Okay.
But
We-
it is on different system. Like I
Okay,
am not.
I can share my screen if you like, if it's easier. Yeah. Okay. All right. So let me share my screen. So I'll just show you where you can download this code if you do want it. So give me 1 second. All right. So today we'll be using 2 repositories. So the first one is Terraform modules. So this is one repo that I just use for, you know, a consolidation of all my Terraform modules, and just something that I use personally, mostly for Kubernetes clusters. So generally everything here is just to provision Kubernetes on Google, Azure, and then today, someone said that if we use GCP, it will be more beneficial. Ben and I have actually done a talk on GCP as well. So let me just find you the repository here. We have a talk on it as well. Oh, sorry. So if you do want to do GCP, you can, I mean, even here, you can just follow the repo and put GK. So this one here will give you all of the modules in GK as well. So you can see here, like Kubernetes, for example, and that will point to my modules folder as well. So Ben, if you can find the video link on that, please, and add it to the chat, that would be great. Yeah, so not getting good tutorials on GCP, that's fine. We've done lots of that as well, so we're happy to show you. So yeah, like I said, the repo for the modules is here, and then we also have repo for AKS as well, but because we're starting new, we'll do it with EKS. So I've gone ahead and cloned that already. So let's look at the modules folder as well. So this is what it looks like when you clone the modules folder. You'll see that what we've done is we've segregated it by provider. So whatever the provider name is, we'll put a folder. So you can see here that we'll work on a lot of networking first. So we'll build a network that will, so somewhere that we can put our cluster in, and then, yeah, we'll go from there. So we have things like VPC. Okay, so here's the GK tutorial if someone wants to watch it. We'll put a link to that afterwards as well if that's too long to copy. So yeah, so here's today we were starting to work on AWS EKS cluster, which we'll fix up today, and yeah, we have the networking to start with as well. So let's get, so this is another repo. Let me find my EKS one. And if anyone has any questions, please let me know as you go. And Waleed as well, if you want to come onto the stream, let us know as well, as you're lots of experience in AWS as well. So this one was pretty much a fork of the AKS. So yeah, let's get started. So Rukshai, do you have any, so these are resources at the moment. So what we can actually do is, this is how you would do it if you were not using modules. So this is something that's really important to understand as well. So and you don't need to use modules every time. Like there's use cases where you can not use modules and just use a resource. So essentially what a module is you're just calling your resource from a different place. So you can make it more dynamic by adding variables. So a good example is maybe, let's say tags, for example. So if you have different environments, you want to have different tags as well. So one of your tags could be environment equals dev, or application equals web, something like that. So yeah, essentially the first thing we'll do is a VPC. So in AWS, that's our network that we want. So we can also, let's reference here as well. So if I go Terraform modules, and then let's look to see what we have. So in the modules folder, we have 3 files. We have the main.tf. That's where we keep the resource code. We have outputs. And this is just a practice that I like. You don't necessarily need 3 files. You can have it in one if you want. Terraform will work it out, but I generally like to split them out. And then variables as well is what we're declaring. So yeah, there's lots of different options for variables as well. You can use the parameter default as well if you want a default parameter in there, like a string, or if your tags are common or something, you can put default and then keep the tags, and that means that your user won't have to specify that variable. It will pick up default. If you don't put default, then they're forced to specify it because your module is going to ask for it, if that makes sense. So here you can see that this is actually somewhat hard-coded. So yeah, generally hard-coding is not that good. I'm not too worried about this one in particular, but reasons why hard-coding could be good is that if you have development teams consuming your modules, then you might want to bake in security. Like, for example, you want the latest TLS applied, and developers can't choose 1.1 or so security is a good one. Generally as well, you don't have just one resource. You probably have quite a few resources in one module, because if it's like for like, then it sort of becomes more code as well. So you could have different things in here, like a subnet as well, maybe. But today we're just going to keep it really simple and just more or less like for like. But generally what we've found, haven't we, Ben, is like we normally do quite a few, because generally for some services, you're always going to have another resource anyway. So it makes sense to keep it as one module, because at the end of the day, like as a DevOps engineer, you want the software engineer's job to be as easy as it can. And they don't necessarily need to know what's going on in the cloud as much. They just worry about focusing on their code. So keeping your modules, with enough resources and variables, so that they can, if they want to consume your modules, they can do that easy, and they don't have to worry about the other stuff. So
the most convenient thing that we had with a lot of the modules is sort of like a Boolean flag that says, if you're deploying, say, resource A that has potentially 3 other dependencies in it, you can do, does dependency B need to be deployed, true or false? Does dependency C? That's how we had done and structured a lot of these. That's just one module that does multiple things, and you just choose what exactly you want it to run.
Yeah. So yeah, here. So yeah, let's look at let's look at AWS VPC here. So the good news is that the Terraform documentation is really, really good. So Ben and I, we always use this. So I just go here, simply AWS VPC. Generally, you can copy and paste this, and then you can see your argument. So you can see here that's having availability zone, the silo block, and VPC ID. So you don't necessarily need to use data. You can just have that as an input, or you can reuse the ID from another module above. So what that means is that if you have outputs, so see here, I'm using VPC ID. So that means that in the subnet module, if I use that, it's going to ask for a VPC ID, and you can say the AWS VPC .default, what you specify is like, give me the ID from that because I want to feed that into my subnet. So that's super useful when you're automating infrastructure as well, is that you can use the ID of something that's going to be created or just been created. And anything to do with VPC is in the argument reference. So that can be a parameter here that you can see. So I know this takes a while to get your head around, but once you do, it's very powerful. So you can see here, you can pass in your IDs, tags, like we always try and there's a few services that you can't put tags on. It's generally 80% or more you can tag, but we always like to enforce tag. We like to have a tag saying, so what a tag is it's essentially metadata tagged to a service saying useful information that can use. So you can use it for observability tools like Dynatrace, for example. It's a way of leveraging other tools where you don't have to change anything in the code as well. So like one example is we like to say provisioner equals Terraform, and then we know that Terraform provisioned that service and no one can delete it, because if you delete it, that's going to cause trouble as well. So and then
the other useful tags that we tend to use is because we want Terraform is meant to be source controlling everything, right? That's why we tend to put in one of the tags the repo where exactly is the code that stores the Terraform code that is spinning this resource up. So we have a tag that says repo and the repo URL in there. So it could be github.com/BradMcCoy-EKS in this particular example. That way, when someone's in the portal and looking at any resource and they are trying to make any changes, rather than go click around in the portal, go to that repo link and make the appropriate change in Terraform and let it apply instead. So that's one of the more common tags that we use. Owner is another tag that when you're working in multiple teams, it might be easier for you to be able to understand, all right, this is under which team's domain. Who should I speak to if there's a bug with this program, for example? So many things that you can use tags for. Those are just some of the examples that we have been using thus far.
Yeah, so there's a couple. We have environment owner. Repo is good as well, because if you want to know to make changes to that service, you can go to the repo to find out, where you can do a pull request to change it. You can add as many tags as you want as well. The more, the better. Actually, it's quite a tagging is quite a key for automation. If you tag well, then your automation is going to be so much better.
And it's free. You can tag as many as you want, and you don't have to do anything.
Yeah. So that's an example of adding tags. Or attributes reference is essentially an output. So after Terraform has provisioned the service in the cloud, it will then give us, ARN that's a very common one, because ARN you're going to need for other services as well when you provision them. And that's where you put it in the outputs folder. So you can see here. So what we can see is if we go like this. So we have the main here, and then we can see that normally we just call them default, because generally there's only one VPC in a module. So it's easier for copy and pasting essentially. So I'm saying this is how you reference that resource, aws_vpc.default.id. So, and you can, and a key thing to remember is if you don't use modules, you don't have to do that. But, well, you do have to do that, but it's in a different way. So, I hope that makes sense. But you can put all of that, and you can make custom outputs as well. So one useful output that I normally do this is, yeah, so I put to get my kube config, this is like Go syntax, but you can do this in AWS as well, but essentially I just say AZ AKS get credentials, and then with the cluster that I do, I use this is for Azure, but I use the resource group and then the name. So it's just a little helper that I can connect to the cluster straight away after I provisioned it. So again, super helpful for automation, because if infrastructure as code is your first stage in your pipeline, and then maybe you do application configuration, you can pass variables or outputs onto the next stage of your pipeline as well. So really helpful thing, outputs. Do we have any questions so far? I know that's a lot to take on if you haven't seen it before. Brooke-Charlie, do you have any questions?
Yes, I have one question. Like, see, you have took the output in ID, right? VPC ID. This output, suppose if I want to use in like a subnet, like we give ID of VPC in subnet while creating it. So how can we like use it there? This idea,
Sure.
how?
Yep, good question. So let me just get rid of this. So if we go back to the EKS, so here we have network. So first, let's make this module style. So I think I sent you on Slack before. Let me just pick that up instead. So this is an example of when I used it without. I think actually this was maybe a module for, I made a big module for the whole network, but today we're just going to do the small ones. So let me just get the code for that. So we also have to link it to the Git as well. And we can do different release branches as well, which we find super helpful. And then each time we change something, we can tell the developers this is the release notes for this cycle. So see here, okay, so this example is when I was using it in the modules folder of the same repo. Now, as an improvement, I've actually moved it away to the Git repo like we showed you. So this is how you would call your module. So what that's saying is, if I was here under because this network file is in the source folder, I would then have a new folder called modules. And then that would have a folder AWS network, and then VPC Terraform. I used to have other, like CloudFormation and stuff templates in my infrastructure as code repo, but now I've just split it all out to Terraform. So let's steal this from here. So what this is going to do is it's going to go look on GitHub, because I've got a public repository. You can have private too, but you have to make sure that your computer or server has the access to that Git repo. And it's saying github.com /dev Terraform modules. The folder is AWS, and then this one will be AWS_VPC. And let's confirm that. So see here, folder AWS, and then AWS_VPC. And we have those folders like I showed you in the repo. So the cool thing is that, well, then when I say Terraform init, like we've done on the other talks, the Terraform init is going to say, okay, I'm going to initialize this code. I can see that I have external modules outside of here, so I'm going to pull them down as well. So Terraform will look up that module. It'll say, okay, the source is in GitHub. Let's pull. Essentially what it does is it goes there, downloads it into my computer here. There'll be a .terraform folder, and that will pull my modules down. So that's how you can reference external modules, and that's very powerful because you can version control it. If you do version control, then you can have I think it's something like ref equals 0.0.1, for example, which would be a release branch, or you can do a tag as well. And then you know that breaking changes won't be introduced for your development teams, because we had around, I think, 5 or 6 development teams leveraging this. So we had to make sure that, and then Hamid just asked a question. So there is a dash that's correct, and that's expected.
I was waiting to talk about that. It wasn't a typo. That the way the double slashes work is it's quite intentional. When you look at the format, github.com, Brad McCoy Terraform modules, that is actually the actual URL in GitHub. The double slashes there signifies that you stop at the URL and then you go down into the folders of AWS and VPC. So it's actually completely intentional to have the double slash in there when you have the Terraform modules in the format that is currently being shown, where you have folders and subfolders that contain multiple modules.
And that's a very good question, because in fact, different source control will have different conventions. So if I show you one of my work ones, that's using Bitbucket, so we'll be able to see that. Sorry, I've got a lot of repos. I'll find one after.
Service key would work if that. I think I saw a service key before.
Service bus.
Either one.
Yeah. So here we can see that if we, so this is using Bitbucket. So you'll see that this is actually a private repo, but no, it is the same actually, but you'll see that this is a little bit different as well. So it's just important to know that different source control have slightly different conventions. So here you'll see that there's the git.ssh.
GitHub is special that it's sort of like the first class support from Terraform, that it allows you to just put a URL, whereas in the other ones, Bitbucket is you have to use a generic git ;SSH to be able to get into it. Bitbucket, I think, I can't remember which is the one with the orange fox logo, GitLab or something. That would also use the same syntax.
GitLab, yeah.
GitHub is the one that gets special extra love from Terraform. Uh-oh, Brad's glitching out.
Which is good.
Well, yeah, he's back. All right.
Because generally, I like GitHub as well. I mean, it's come very far in the recent years. Yeah.
I think we have lost Brad for a bit.
It's because I'm opening too many Visual Studio Codes.
All right, he's back.
Yeah, can you present, Ben? Because you there?
Yep, we can hear you.
I can't hear you.
I think he's.
Can you maybe present?
All right, I might go over.
Can you present your screen, Ben?
Sure thing. One sec. All right, so Brad had mentioned a bit about modules and the inputs and outputs of how modules work. Do we have any questions about modules, how exactly they work? So we had mentioned a bit about how they're sort of like, just like any other method or function in any language, you are just able to reuse them. And how we've been using it thus far was that's sort of the module source options here that we had briefly mentioned about. Now, Abhimanyu, that comment that you had there, the // that is exactly one of the options on how to source a module. Using the /, that means it's a local module. It sits right alongside your Terraform code. And the other option that we had been showing you before with the github.com or the git :// stuff, that is an example of a remote module where it just pulls it from cloud storage somewhere. So that's how exactly you use the different modules.
A quick comment on that as well is, if you're starting off in modules, it's confusing, right? Like, you can't just learn this in this session here, but take some time to play around with it, to understand it, and just start with having your modules in the same repo, the same folder. So it doesn't even need to be a repo, it can just be in the same folder. So use the / that I showed earlier on. You can reference this video back and just practice then, and then iterate like we did as well. This is my best advice for that.
That's the perfect playground for testing new things, because you don't have to, if you're using the Git version, that means that if you make any changes in the module, you're going to have to git commit, git push up to the cloud storage somewhere. And in your other repo where you're actually deploying the Terraform code, you're going to have to Terraform re-init and re-download the module. So it's a bit more tedious in your constant development type thing. Whereas when you're doing it locally with the file source /, any changes you do in that same repo, it's immediately live. You don't have to Terraform init again to re-pull the modules. It just knows that local module, okay, I'll just scan it again, see if there were any changes that have been made in the modules folder, and then I'll rerun it. So that's quite convenient for trying things out. So definitely that's what I do as well. Whenever I'm doing or creating a new module, before I even push it up to the Git Terraform modules repo, I do it locally on this // version, test it out a few times. If it works, then I'll take that code and commit it into the Terraform modules repo to be made publicly available to all the other devs. And on that end, they will then use the Git reference to pull that specific module down.
Yeah.
Aside from that, finding using modules. So modules that you can see on Terraform's registry, let's see. Some of them are quite good. Let's go through that. I'll just click on any random one.
Ben, when you've used modules as well, what's something that was maybe challenging to understand or took a little bit longer to grasp, if that makes sense?
I think one of the main things, the biggest hurdle that I had with modules was understanding how to pass parameters from your main.tf up to a module, and that gets passed down to all the separate child resources of sorts. So here is one example of a VPC module that source Terraform AWS modules. I think this may or may not be an official AWS module, but they work similarly enough. You do it in the same way.
It is official one. It is official.
This is the official one, right?
Yeah.
So exactly what you see here, tags, how I would do this is, instead of writing this Terraform true environment dev, I would make this a variable, because I will be using this same tag in not just my VPC. I'll be using it in every other resource as well. So tags equals tags, a variable of tags that I just pass in everywhere. So when this gets passed down into the actual, inputs. So this is how a well-documented module would be like. It tells you exactly what it accepts, a database subnet assign, which you can see it was in here. It wasn't. Well, it has a lot of options apparently in this thing. VPC Terraform module, VPC, NAT gateway. So let's see. Yeah, it allows you to pass in a whole bunch of these parameters, and it tells you what exactly it's expecting. A Boolean, so a true, false, string. So it gives you a lot of options of what exactly you can do with a module. Let's see, I don't know if I've got a live example that I can pull out at the moment. Let's see. Let's start with, oops, wrong one. On my repo. Yes, I'm a stormtrooper. Okay, so let's perhaps go through, because I've mostly worked in Azure, so a lot of my examples are Azure. Let's see, is there an app service, key vault, secret, bastion host? Key vault? Okay, so this is an example of a key vault thing. Hold on.
I'll make the screen go bigger and take us off it so we can see the whole thing. There you go.
Yeah, I'm actually gonna see if I can. Darn, I don't have any of my repos cloned on this particular computer.
Oh, okay.
I was hoping I had one of the bigger examples that has more things involved in it. Let's see, resource group might have a few things. There you
the
go.
billing alerts. Yeah.
Exactly. This is an example of one module that contains multiple things. So in Azure, you've got a resource group, and
Sorry
you've
to
got.
interrupt. Can you just zoom that in? Just maybe Command plus.
Is that big enough for?
Oh, that will do. Yeah, that's fine. That's perfect. Right there, that's good.
All right. So this is an example of creating one resource, creating a second resource in here. All right. So this has two resources. All right. What this module does is when someone wants to create a resource group, it would tie in together with a budget. That's quite handy. When you create a resource group, you want to be able to tell someone that, well, send out alerts when you're exceeding, I don't know, say $50 a month or something. How we use this is through the main.tf and variables. This is how we get the developers to use. So things that you're supposed to pass in: the name. Obviously, you're giving the name to a resource group, location, where exactly it is, budget amount. So this is an example of a default. So how this works is, if the developer does not pass in a specific budget, say $200 a month, the default will just go to 0. And contact emails, same thing. If you pass in a list of string, like in this case, there's Brad and Emmett. There's two people on the list that should get notified if you exceed a certain budget. Again, this is the default. So if you pass in contact emails equals bob@abc.com, Bob will get the email instead of Brad and Emmett. Same thing with the tags. In this case, there's no default value, which means if there's no default value, what the developer would have to do is you will have to pass a value in. Otherwise, the Terraform CLI will just, well, get a little upset with you. It'll say, I'm expecting this. Please provide a value in standard input. So works fine if you're running Terraform on your local computer. You can always just type in saying that, yes, I'm supposed to alert Bob. But if you are running this in a pipeline where it's like fully hands-off approach, that isn't an option. Your pipeline would just be sitting there and eventually timing out because it's expecting a standard input, and you can't do any standard inputs in the pipeline. So let's see, one of the questions, these are modules that you build over time based on your requirements and you use later in your Terraform scripts. Exactly, Pavan. This is basically the whole reason why we do modules instead of just plain resources. As an example, why do we use a resource group? Just like, why should I use module instead of just typing out a standard resource like this? Well, for future-proofing purposes, if I use this as a module, eventually, a month down the track, when I've decided that as a company we're supposed to implement these budgets, that's how I can add this particular resource into the resource group module and be able to add new functions, new features to grow out the capabilities. So this is one example with resource group. Let's see if there are any more slightly more complicated ones.
a good example as well is like if you're studying this and then you're adding modules as you learn, you can take this to your next job as well. So if you're at an interview and they say, what's your experience in AWS, or you can say, well, I have all of these modules ready to go, so you can push a button and spin up all these services. That's really powerful. So you can reuse it at your different jobs, and it's good business wise and then personally as well.
So that's a Kubernetes cluster. These are modules are really handy in the sense like this kind of Kubernetes cluster where some of them are big, some of them are a bit more complicated. You could always, search and copy from, like, let's say if you had done this one Kubernetes cluster in project A, it's good, you've got it in project A, and when project B comes along, you decide that you need to, recreate a similar cluster. You could copy the entire resource block across, but now you're going to have some, drift in your resources that if in project A you decided that you're supposed to hard code that the maximum amount of pods is 200 rather than, 2,000. So do you go into project A and B and update that value 2 times? Or if you just create one module and get every single project to reference that one module, the moment you make a change in that one module, it applies it across all your different projects, keeping them consistent. Now, that might have been an extreme example where I, hard code something to 2,000. Whereas if it's something that's supposed to be a variable, you can do something like this. Node count is var node count. So in project A, that count could be 5. In project B, that could be 300. Just throwing random big numbers out there just because I can.
And environments as well, right? So like if you had prod,
correct, yes, exactly. Because that's the handy part about using all these variables, that just because the node count is 1 in dev does not mean that in prod it has to stay as 1. It could be passing through the tf-vars file that I believe we had covered in earlier sessions. So your prod could have 10 nodes, whereas your dev would just be a single node. So that's, I suppose, how the benefits of using modules, I guess. So that's what we had covered over here. Define module versions. We had sort of touched on that using what Brad had mentioned before with the source. Let's see. Terraform's version. There you go. This is one option of how you can write versions. The other option is what we have been doing with the release branch, with the query string style $ref equals something. That ref equals something that's specific to Gits. So in this case, like you see here, there's, let me see, get it from the main thing. Is there a tag in here with the release? Not yet, but that ref equals that query string, all that's doing is specifically referring to a branch in either your GitHub or your Bitbucket, whichever it is, because you could always have release versions 1.0, 2.0, 3.0, the same way how any of these modules work. So let's just see, click on that. See how they're versioning 4.0 just to ensure that there's no backward compatibility problems. It's the exact same thing that we do in Git, where you create a branch. It's just for demo purposes, I'll just create a branch called release 0.1.
0.0.1 is better. Yeah.
0.01. So with that branch, let's just say with 0.0.1 in Azure RM, this key vault would have this exact set of values. Whereas when I go to, further changes have been done in the development stage, have been merged, and eventually I release 0.0.2, whatever is in 0.0.1, this is, like a frozen, locked down module, there's not going to be any changes. Like in this case, I have, say in 001, I've hard-coded that I want a KV suffix to the names. In 002, that may no longer be the case. The KV might be taken out. So that's how you can use that as a form of versioning for your modules, either through Git or through stuff like this, where damn it, lost it. I think it was that one. This is the other option where in your module you specify a specific version. So I guess that covered a bit on the different module versions. Public registry, Terraform Module Registry. I personally have not been using the Terraform Module Registry's modules much. I kind of like to build my own modules. Not sure if that's a good or bad approach, but I like to be able to know and control exactly what the modules are doing. But there's always the option of going onto the Terraform registry and exactly like this example, and having a VPC module that does a whole bunch of things. So that's also an option. Input. So going back here, input, outputs. I suppose inputs, we've sort of covered it. Like,
maybe a good example would be to show from what we call level 1, but how they're feeding the variable into the module. Maybe we haven't shown enough of that.
Yeah, I'm trying to see if I actually have anything of that sort, which
if you go into if you go into the GitHub AKS,
true. Yeah, the AKS would have it.
Yeah.
Okay, just search through the repos. I feel like I forked it, but I can't recall for sure. Whereas I know it's definitely in here. Okay, so this one's a module. There you go. So, all right, let's open these two side by side. Do I still have Terraform modules in the list? Yep.
This is a good example because it's showing locals, vars, and hard-coded all in one. So I can show you different ways of passing in the variable.
Okay, Terraform module main, Azure RM, Kubernetes cluster. So what you see here, this is the actual resource, and this is the module that is calling the resource. What you see here, this source here, GitHub, Bramikoy, Terraform modules, that is calling this Terraform modules, and the folder structure, Azure RM, Kubernetes cluster, and that being a folder that contains multiple things, that's what it'll pull through. So firstly, you will need to, when you reference a module, you'll need to provide the values of, well, basically every variable in here. Oh, darn, I just realized I'm only sharing half the screen. Sorry. Whoop, wrong screen. All right, so on the left, this is the module. The source is this portion here. Now, what you'll need to do is actually put every variable here, like name, you pass it in here. Location is down here, resource group name. So every variable that is declared will need to be addressed in here. Go away. It'll need to be source name, DNS, all that stuff. Anything that does not have a default. In this case, none of these has any default. So all of them will need to be passed through. You'll see name, DNS prefix, all the values are in there. Now, when you do run a Terraform init on this, what it's going to do is it will pull this entire folder down. That way, it will store it locally on your development, on your machine, whether it's a virtual machine like in a pipeline or in your actual development machine, either way. So it just pulls it down, it checks and ensures that all the variables are addressed, and then it starts, well, trying to deploy. It will run through the same steps as if this whole resource was copied and pasted in here with the relevant values substituted. Abhimanyu is requesting a module live. Woohoo! Fun times.
And also, just on that, Ben, I guess it's a little bit more advanced, but it's also good to know that you can do the validations on variables as well. So, for example, the string must have 3 or more characters, or way more advanced than that. But and if you put a type, so that string, obviously it must be a string, like it can't be like an integer or so. One sort of I wouldn't call it a cheat, but sometimes I don't put type because Terraform will work it out what it is. So sometimes I don't put type just to sort of be assured that I'm not going to do the wrong thing.
Cool. Let's see. It's fun challenge. I've never done an AWS thing before, so let's see if it works. Let me just create a new folder. One sec, just creating a folder.
There was a very good call out as well to make one live.
Yes, I trust myself. All right, let's start with PDF. Okay, so S3 bucket. Let's see. And I'm going to need quite a few things like this.
I didn't actually know that you can click the provider like that. That's very cool.
It is. Okay, let's see. Let's just try a Terraform init. That will get the AWS provider. I don't know if I'm going to actually be able to deploy one of these because, well, I don't have an AWS account signed in. So Terraform init, at this point, it just downloads the AWS provider. Terraform validate. It should validate that, AWS is okay. So if you start doing things like taking out required values like that, I assume validate is going to get angry with me. Can you actually create a bucket without passing in anything? That's a bit fun. What is a required value in the bucket?
Just, it should be name. Name should definitely be one.
Bucket is optional.
Wow.
Oh. You
just get a random unique name. Cool.
Yeah, okay.
All right, that was a bad example. I was hoping that would fail, but anyway. So this is a S3 bucket. Let's see if there are any values like force destroy optional. Should be deleted so the bucket can be destroyed. All right, force destroy. This is an option. Let's see. Oops. Force destroy equals var.force destroy. Okay, so using this as an example, for now, I'm just going to make them all in a single file just because easier for everyone to look at in one go. Type equals Boolean. Default equals false. Okay, and this is when I start getting into a bit more specific where if you look at force destroy, what exactly is it? I'll start naming things as S3 force destroy. All right, so that would probably still work. It's still happy. Okay, so now if I want, this would work just fine as a standard S3 bucket. If I wanted to convert that into a module, let's start by creating this as a module folder. New file, main.tf. outputs.tf. This is all just keeping things nice and neat. Okay, so main and this main. So what we're going to do, take all that, pop them in here. All right, save that. By itself, that would, so I'll just save that. And now it's first thing that I'm going to do to convert that into a module is actually call it a module. Call this my S3 bucket. All right. Source equals, in this case, because it's a local module, we're going to do that. Module slash, sorry, I should do this. AWS S3 bucket. Now, the reason why I do this is because eventually you're going to have more than one module. So say AWS other module, just as a placeholder example name. So what you do is source slash module slash AWS S3 bucket. What this then does is it knows to go down in there, go down into the S3 bucket, and read from here. Main outputs variables. So, okay, let's do this. I'll take that out. Now, when you first create a module, what it's going to ask is for you to rerun Terraform init. See, it's going to say module is not yet installed. Terraform init. All that does is it sort of processes in memory that, all right, for this module, I'm supposed to look inside that folder and not online in a Git repo anywhere. So now if I run Terraform validate again, it's going to get angry because in your module, it was expecting that, but the variable has not been declared. So what we would then now need to do is, let's just make things all much more comprehensive. Bucket name. Tags, I'm just going to leave that hard-coded for now because that's not really part of what we care about. So variables, I'm going to take this, force destroy, that here. Now, so we're still looking at just the S3 buckets, 3 items, main, variables. So there's an S3 force destroy. The other variable was bucket name. Sorry, I'm not sure if this was big enough. I should have zoomed in a little before I typed too far. Bucket name, type equals string. Default, I'm not going to pass in the default value in here because I want it to be hard-coded. I want this to be always something that the user passes in. Save that. Save all this. I can take that out now. Okay, so it's still creating an S3 bucket. Hit save, validate. Bucket name is required, but no definition is found. So that's what it's complaining about here. I'm trying to create an S3 bucket, and it's looked in the variables of this S3 bucket and said that I'm supposed to pass in the argument of bucket name, but I did not. So what I'm going to have to do here is bucket name equals demo. I'm not sure if you can do underscores here. Demo S3 bucket. If I run validate again, it'll be happy. So as an example, in this variable where I've got force destroy default equals false, and default's pretty self-explanatory, but if I wanted to override that, I can just go S3 force destroy equals true. So this is, well, a quick show of how you can create a S3 bucket module. And if you wanted to create multiple of the exact same bucket, let's just my other S3 bucket. And it's also referring to the same module and demo S3 bucket. I should say that. You validate again. Now, whenever you create another module, it will ask you to run Terraform init again. Just do that. Validate. Now that's happy. So when in this case, I've created this S3 bucket, and any changes that I do in here, let's just say if I had something that I want to do, bucket prefix, conflicts of bucket, object lock configuration. Okay, let's try that one. Equals. I'm just going to say true for now. Now, I've just added a new configuration in there, and that is applied to both of my modules now because they're referring to the same source. And again, validate, that's going to be fine. Enabled, so it wasn't expecting true, it's expecting enabled. There you go. Imagine if this were a resource. Instead of doing this as a module, if this was a resource, I would have had to change the true into enabled twice. Whereas now that it's abstracted away into a module, you just do it once and it applies across all your instances. So I guess that was a quick, speedy introduction on creating a module. One last bit on the outputs. So outputs here is, let's see, ID. This is one of the options. Output ID. Value equals, let's see, what was that thing called? I shouldn't have called it B. Just call it default. Value is that dot default dot ID. Out of format. Surprised I didn't format it. Anyway, so if I wanted to refer to the outputs of that, what I would then do is output first bucket ID. So now you'll see the difference between creating an output, retrieving a value of a module's output against a standard output, which is this. If you're doing a resource, to get the output, it is resource name resource type dot resource name dot value, which you saw here, resource name, resource type, resource name dot value. But when it's in a module, what you do is module dot module name dot the specific output that we had specified here, so ID. Now this is something that could get a bit confusing when you do it for the first few times, but after a few runs, you'll see how that works. Let's see here. Sorry, Terraform validate. Okay, bucket ID. What's this? Output name. Outputs don't allow that. ID 1, ID 2. There you go. So this is an example of how to do modules.
I have one question.
Sure.
See, you have given the bucket name over here, like demo S3 bucket. Is there any other way, like we can give the names here?
All right. So right now this is demo S3 bucket. Let's just say what
It's
you
like
would
we have written over here directly. Is there any other way we can do this?
definitely. So let's just get things nice and neat, variables.tf, I'm going to create a new variable called buckets list. Right, equals this string equals list of S3 buckets to create. Right, so this is a list of buckets. Then what I would then be doing is passing in, do I want to create a TFR? So I'll just put it in as a default for now, equals, one, bucket two. All right, so it's an extendable list of bucket names. Now, if you go in here, what I can then do is do it something like this. For each dot buckets list, what did I call it? Buckets list. Now, for each of the buckets list, it's a list of bucket names. This might actually get a bit complicated. Let's not do it as a list of strings because that makes it a bit uglier to look at. Just call this bucket one equals storage. I'm just going to use this as like a description. Bucket two. All right, so for each of these things, what I'm going to do is bucket name equals each dot key. So this would now get a bit broken. The outputs of this might get a little hazy, so I'm just going to do something like that for now. Okay, so what is happening is you're going to be creating multiple buckets for each of the storage buckets in here. I wonder if I can do a plan without signing into AWS. No, it's not going to let me do that. So having this like this, what it's going to do is it'll create a first bucket with the bucket name bucket one, second bucket with bucket two. And that just creates two separate modules. And the way it would work is if you wanted to output that, you would go S3 bucket, and this is bucket one .id. Obviously, you wouldn't be doing this as a hard-coded thing because you're not going to be able to get that value. So there will be some trickery involved in getting this output the way, in a more straightforward way than this. This probably isn't the best example for doing an output, but if we just ignore that for now, this is how you can pass in values and create multiple buckets. Or in this more simple example, it's variable name This is how you can make it like a bucket name like that. And in the example where, we've got a dev or a test or a prod type thing, you would have dev.tfrs bucket name equals bucket, something like that. You can have prod.tfrs that says prod bucket. And what it will then do is when it creates this in a dev environment, it'll pull the value from here. In a prod environment, it just pulls the same thing. Did that answer the question? Or just made it more confusing?
No, it made clear.
Cool. Great. I don't know if I don't see any further questions. Is there anything that you're unclear about? Otherwise, we might just wrap it up at this point then.
Yeah, it's okay. Everything is clear. Thanks.
Great, cool. So that's an example of a module created live. Hope you guys enjoyed this talk, and well, hope to see you guys, girls, everyone, at the next session where we'll be talking about. Let's see, what was the topic? I've closed that tab. Anyway, it's about the different Terraform workflow using init, plan, validate. That will be run by Hamid again. Let's see. All
Yeah,
right, that's a question. Not related to meeting content today. Why use provisioners, and what's suitable technique for this aim? Okay, provisioners is, I believe that's something that you had spoken about,
yes.
Vrukshali, wasn't it?
Yeah.
Provisioners. Do you
Yeah,
want to
like
talk about that one?
yeah, there are two types of provisioners, like local execution and remote execution. So provisioners are like if we want to run something, like configure something on the server. So Terraform itself says that running a provision using provisioners is not recommended, and it's not a good practice. So like we can for this, which is a suitable technique. So for this you can use like configuration tools like Ansible, Chef, Puppet, and like you can after like infrastructure is created, you can run those Ansible and Puppet, Chef's playbooks. So we can do this. Am I
Yeah,
right?
that's just correct. I'm just gonna show a little example here. So we did the deployment. So this is an example of running a local exec provisioner. Once the S3 bucket is created, local exec just means something that's run on your terminal. It will literally just do that. This die. So literally just paste this in. Crap. What happens is it just echoes. I have completed the deployment. Horrible typo. Now, obviously, echoing does absolutely nothing. So what could be more useful is, say once the S3 bucket is completed, you could do curl to, I don't know, mywebsite.com, curl to that with a payload that says, deployment is completed. But for the most part, you shouldn't really need these provisioners. Hope that answered your question, Hamid.
Yeah.
All right.
Next question is, can you please show data source?
How to use the data source? Sure thing. So data source, S3 bucket. All right, data. Resource. Where is that data thing? Data sources. All right, let's just use that one as an example. The data AWS instance, connect instance. I might need to choose something I'm more familiar with, like that. Okay, so an AWS instance, you would know that it has various information. Like in this case, you would have the ID, the AMI. I wonder if there's like a password of some sort.
Can you share your screen?
Oh, whoops. Share screen. All right, so as an example, a data source for an AWS instance. So it usually requires a few things. Prerequisite information, like in this case, you can pass in, let's see, what's at least one of filter instance tags or instance ID must be specified. Usually ID is probably the easiest one to use. So if you provide the instance ID, it will be able to, what it's going to do is it goes and searches in AWS. It checks the instance ID and says, all right, I found AWS instance called foo in this case. So it goes in there and it retrieves the information related to that specific AWS instance. Now, what information exactly? It's everything that you see in here. You're able to retrieve, say, the password of that, the private IP of the AWS instance, and why exactly would that be useful? Let's see. Let's just say, I don't think this is actually something that is available. Is there an access control thing? Okay, let's just pseudo code this a bit. So IP allow equals, say, something like this. This part obviously wouldn't work. This is just
You can also take a simple example for like finding the AMI ID using data source.
Yep. In this case, I'm just going to roughly copy some of these things.
Okay.
Okay, copy. Why is that not copying? Okay, so as an example, this IP allow is data.aws underscore instance dot foo dot. I can get the IP address of this private IP dot private. So this is an example of how, if I want to get the IP address of that particular AWS instance, you can use data.that to be able to retrieve the IP instead of you going into the portal, finding what the IP is, copying that, and pasting this in like this, because the IP address would probably change every time you redeploy the AWS instance or S3 bucket or basically any resource altogether. You just use data to be able to get the latest up-to-date information and pass it on into your configuration. So this is an example of how to use a data source. It is also useful for, I wonder if S3 bucket has an example. Resource, S3 data source, S3 bucket. There you go. ID, bucket, website endpoint. All right, so there's no connection string to it. Website endpoint. All right, so this potentially may be something that's useful, like a website endpoint using the S3 bucket thing. If, for example, you wanted to do an output of what exactly is the endpoint to get to an S3 bucket, you can use similar thing, data dot in here, data dot AWS S3 bucket dot selected dot website endpoint. That's how you'll be able to get access to all this information. So I hope that answered your question, Abhimanyu. Sorry if I'm butchering your name. All right. Is there any further questions from anyone?
No.
How about you, Rukshali? All good? Did we sort of cover the things we wanted to address it with the modules?
Yeah. We covered
Perfect.
everything.
Perfect. Well, I guess that's going to be a wrap. Thank you, everyone, for coming, and I'll see you all next week.
Yeah. Bye.
See ya.